Success is for those who hunger perfection and are ready to triumph through hardships. For every budding student eager to prepare themselves for tomorrow, we present to you DAKSH 2022. Ladies and gentlemen, a very good morning to one and all present here. Christ University is proud to welcome you all to this edition of DAKSH, a career guidance event of the university. I am Mayank Kashyap along with
Jisha Charian.
From School of Architecture, we'll be the MCs for today.
We have in our midst today the respected Father Jibby, Dr. Father Benny Thomas, Dr. Father Ibrahim in their absentia, Head of Department, School of Architecture, Dr. Anita Sushilan, Heads of Departments, Professors, Students, and our Honorable Chief Guest, Dr. Ella Manjunatha. Thank you so much for being part of this seminar. Before we begin our session, we request you to join us for a silent prayer. Thank you. DAKSH, the annual Education and Career Guidance Fair, hosted by the Student Council of Christ, deemed to be university, is a one-stop destination for all things education. To make informed choices regarding your education and your careers in architecture, we present today's session, Future of Construction and Architecture Industry. Now, we would like to request Dr. Raghunandan Kumar, HOD of Civil Engineering, to share a few words.
Very good morning to everyone. So respected Chief Guest of the Day, Dr. L.R. Manjunatha, Head of Department, Dr. Anita Sushilan, all senior professors, dear colleagues, and dear Christites. So first of all, congratulations on organizing this event and inviting the very apt person for today. I'll speak very briefly. I'll not be talking about what we did as senior professors earlier, but when we look at the construction industry, so from the statistics, what we have, it is about $11 trillion industry, construction industry. That's a huge amount when we compare to manufacturing or service industry. And it's also growing. By 2030, it is expected to grow to about 16 trillion. So if you're all wondering, with this 11 trillion, where can we source the materials from? And if it is growing to 16 trillion, now where else can we get all of this material? So sir also the other day spoke on the net zero. So as architects and engineers, when we develop or conceptualize spaces, what I advise is it has to be timeless. For the reason that we know that many of the natural resources are becoming very scarce. Now we no longer get any fine aggregate that is sand from the natural sources. Of course, we have alternates now. And the aspirations of the people also, when they want to use these spaces, are changing day by day because of the technological advancement. So it is the responsibility for all of us to see how we can meet their aspirations by adding value. So when we say adding value, we have so many new technologies which is coming in, augmented and virtual reality, and BIM has become so very important. So if we look at any construction, to take for example building, a commercial building, you have several functions in a building. And it is humanly, I wouldn't say impossible, but difficult to have several layers of this. So with the concept of BIM, it is possible for us to visualize one of these several layers. And having said that, you also have now virtual reality too. All of these tools are available, virtual reality or augmented reality. And as I was mentioning on the scarcity of the resources, so we have another technology which is coming in, which is called as 3D printing. How soon can we use all of this? So 3D printing, not just for the entire structure, even for the materials as well. So where we have proper control and reduce the waste. And if we can use the technology even for construction of a structure as well, including 3D printing, it'll be a wonderful effort. So of course, it is not like limiting an architect's, say, flexibility or vision on what needs to be coming in to the structure. So, but there's a way forward on using all of these technologies and also to reduce on so much of dependency on the natural resources and wastage of these natural resources. As I was mentioning, since already we are 11 trillion industry, if it is 15 trillion, there will be so much of demand for these natural resources. So it is important to focus and see that how we can reduce and have alternate materials for several of the conventional methods. Just now, Professor Ajay Chandran was mentioning, can we have something, sustainable, including in bricks, not, dealt so far? By using several other waste products or maybe make it more thermal insulated, several opportunities are available. So with these words, and we have Dr. L.R. Manjunatha, who is in the field, and is also chairman of ICI, and is member of the BIS as well. So sir has visited us several times and has supported us as a representative of industry, in the stakeholders, as well as in the BOS. So with this, I wish all of you all the best and enjoy the talk, and I'm sure there'll be a lot of takeaways, so you should all write down notes which will help you in the future. So I remain. Thank you.
We are beyond honored to have amidst us Dr. L.R. Manjunatha, our esteemed speaker for today. Welcome, sir. Dr. L.R. Manjunatha is the Vice President of Sustainability and Direct Sales at JSW Cement, a techno-marketing, commercial, and branding expert with an industry experience of 29 years. Having worked in the construction, building materials, and education industry. Now, I would like to call upon Dr. Anita Sushilan, the Head of Department, School of Architecture, to share a few words.
Good morning, everyone. A warm welcome to our today's guest speaker, Dr. L.R. Manjunath. All heads of department, my colleagues, and dear faculty members, both from architecture and civil engineering, all my dear students, Christites. I think 2022 is a very special year for us, especially at School of Architecture, in the sense that we are having two graduate batches. The first two graduating batches, one is from the undergrad and the one from the masters. I think that's a very, very unique moment, and it's going to tell us what exactly the school has been working in the last 5 years with the undergrad students and 2 years with the master's students. I think both the batches are here. I'm eagerly waiting to see their thesis coming up, because which recalls what has been happening and what has been the curriculum, the entire values that is built up, the knowledge base that is built up at school. I think over the course of 5 years at the undergrad level and the 2 years of master's program, we've been instilling 3 basic values. One is ethical professionalism. I think this is something very important, especially in the current era, where you have multiple opportunities, various choices. So being ethical and also being professional is something very important that has been, kind of very consistently nurtured at school. The other one is experiential learning, both at undergrad level and the master's level at varying scales. So what is experiential learning? We do a lot of outreach projects. So the classrooms or the projects or the design exercises that we deal with are not confined to the walls of studio or classroom. We go out, work with people. We have even completed 2 live projects. One is a bridge which was constructed at Wayanad, because one of our missions of School of Architecture is also to participate in the rural reconstruction. So we have built a bridge, and it has been done by the students, and it's our graduating batch, group of 15 students. We started with 15 students, but we have now an intake of 80. So this is something, a very relishing moment at the turn of 5 years. Our 40 intake has gone up to 80. And there has been a welcoming presence of the public also with us. The school has been rated as one of the best schools, and also, it's been received so beautifully well by the society. So one reason I must say is that the way we work with the society, because the school strongly believes that architecture is not limited to just designing and drawing things, but also working with the society for the people, and also having a great concern for the environment, and especially which is at a degrading level in our current times. So this is something very important about experiential learning which has been happening. And one more project, outreach project, which we have constructed is a medical facility at Hallikare Hundi on the suburbs of Mysore district. So this is, in a way, so academia is not limited just to teaching, learning, and designing process, and also instilling values, but values much beyond that. Responsibilities built, within the graduate who is graduating from our school to kind of work, go beyond, the limits which are prescribed typically in academia. Go out, reach out to the people, work for the people. And I must thank the university for this ecosystem that they have created for us. So we've been constantly, very closely working with the Center for Social Action in terms of, reaching out to the right kind of stakeholder. So we just completed with the bamboo portfolio, and currently the last batch and the current batch are working on earth portfolio, where we are working with mud as a sustainable material. So always the question asked to us is, are we going back when we take indigenous materials? Definitely no. We looked at bamboo as the green steel of 21st century, and mud we are looking at, what are the new ways we can look at mud? Exactly what Dr. Raghunandan also mentioned about what is brick, and what are the new ways we can, what are the innovative ways we can look at building materials. So this is something very experiential about the learning and practice that we are helping our students to get nurtured with. Beyond this, I think one more very important aspect is the way that they are connected with working with materials, because it's not limited only to designing, because typically architecture is known for limited only to imaginative, creative exercises. No, it doesn't stop there. We have to work with material. So I must say that the kind of infrastructure which is put together for School of Architecture is amazing by the university. So we have 1.4 lakh square feet of built-up space, and a state-of-art lab facility for both workshop as well as the computer labs. Because this is something, simulation and working at and understanding materials with using the latest technology is something which is the kind of forefront step, I think, as an academia we should be looking at. So these are some of the 3 verticals which we've been looking and working very hard at. And looking at the foundation years, I think we really look at architectural learning and experience, especially in 2 levels. Level 1, it's instilling values, appropriate choices of materials, appropriateness of your decision. We might be having purchase power, but what do we do, how much we do, and what do we buy? And what do we use in the construction, and how do we design? So the entire process is like kind of very strongly embedded within an appropriate choice, and especially in the first 4 to 5 years, we've been working on this. Good morning, Father GP. Yes. So beyond this, At the final years, I think towards year 4 and 5, we strongly look at developing entrepreneurial skills within students, because it's very important for us to go out and practice, work with people, and make our beautiful ideas or amazing, brilliant ideas which each one of you, the younger generation has, to go out and reach out to the public. So the entrepreneurial skills are very important and professional skills are very important. So this is something which we focus deeply into, and entrepreneurial skills are not limited only to become an entrepreneur or even to become an employer, but social entrepreneurial skills is something very important to be developed, and that sensitivity for that. It's not like all 40 are kind of put into the same mold where everyone is going to become an entrepreneur. No, they are given an opportunity to reflect upon, redefine, find out themselves, who they are, and which realm that they want to fit themselves in. So this is something the school has been offering to the students as the opportunity to identify themselves and make a choice of their own career path. Is it in research? Is it in academia? Is it in practice? If practice, what kind of practice? So I think these are the few thoughts and questions which are constantly asked, and also the many of the exercises that we deal with often deal with to help them learn. And something very important about the several verticals of a strategic plan is to meet professionals. I think this event is one such among the various events that we conduct at school. And the pandemic has stopped us from these kind of physical interaction with the speakers. I think meeting professionals is something very important. Meeting artists is something very important. Meeting them, how they work, and when they share the kind of experience and the kind of confidence that they build within the younger generation is amazing. I think with that few words, I welcome you, sir, Dr. Ella Manjunath, to this dais to render this speech. Thank you very much. Thank you all.
It's okay. Thank you, Christ University, for welcoming me. As Raghunandan sir was telling me, I've been coming here last 10 years. So we inaugurated the student chapter of ICI, and we have done a couple of national conferences also here. So architecture department inviting me for discussion on future of construction and architecture. I found it like, okay, I've never been invited by the architecture department, but I have done more than 600 guest lectures in various universities and colleges across the country. And abroad also I have gone to present my papers. I found this a great occasion, because generally architects are the people who design, play with materials, design. And a lot of new technologies have evolved over a period of time. A lot of new materials have come. So being in the profession, in the construction industry, we don't get much opportunity to tell them what are the materials available, what are the new technologies available, because construction industry every day it's evolving. Not only the software industry or the other digital technologies are evolving, construction industry similarly it's evolving. Every day it's changing with new materials. I'm going to talk about the technologies and also the new materials which are available in the market, which can be better used for the construction, to make construction eco-friendly and sustainable. So JSW, I am part of the JSW group. This is one of the largest industrial conglomerate in India after Adani, Ambani and Tata's. We are having a combined turnover about $14 billion turnover, and JSW Cement is part of the JSW group, and this is the world's most eco-friendly cement company. I'll tell you why we have become the world's most eco-friendly cement company because of our continuous innovation in adopting new technologies, new materials in manufacturing. This is the JSW group. We are into steel manufacturing. We are into steel manufacturing, that is our parent company. Along with that, we are into infrastructure, paints. We are the first company in India to manufacture eco-friendly paints and all color at one price. Maybe buying paints for painting, Asian Paints or Berger Paints, and so many companies are there. There is different rate per liter for different colors. JSW is the first company to introduce all color at one price. So very soon, almost in 1 year time, we have become 1,000 crores turnover company, and we are expanding our footprint across the length and breadth of the country. And sports, JSW Sports, we are part of the JSW Delhi Capitals. We are the co-owners. Today, I think IPL matches are starting. We are into Bangalore FC is owned by JSW Group, and Haryana Steelers, Kabaddi team, we own. And we have put a world-class facility to train the Olympic athletes at Bellary. It's one of its kind facility in the world. So, as a group, we are contributing a lot in sustainable development and sustainable manufacturing. Also, we are helping for the social cause through JSW Foundations. Almost in 11 states, we are operating to help the society to achieve its social goals. These are the products we manufacture, basically. All are eco-friendly products. Each and every product we manufacture, we use our byproducts. Either from steel, we have slag, close to 15 million tons of slag we generate from our steel manufacturing. Every ton steel produced liberates about 300 kgs of slag, various types of slag. It was being thrown as a waste product. What we have done through innovation, we have converted into useful products. And whatever product, each and every product we manufacture is having a lesser carbon footprint. We manufacture sand, we manufacture cement, we manufacture ready-mix concrete and construction chemicals, including waterproofing products. So today, I'm coming to the introduction to the presentation, the background, why we should go for sustainable development, and the need for sustainable architecture and constructions. It's very important. As we build, Raghunandan sir was telling, it is $11 trillion industry, going to be $16 trillion industry. Most of the construction are going to come in India and China because we are the two most populous countries in the world, and huge development is going to come. And China and India are the largest manufacturer of steel and cement. China produces 2,000 million tons of cement every year, and 1,500 million tons of steel every year. India produces 500 million tons of cement and 130 million tons of steel. So we rank first and second in the global scale in terms of cement and steel manufacturing, and these two products contribute almost 13% of the CO2 emissions globally. Talking about new innovations in Internet of Things, 3D printing. We are also working on 3D printing from JSW Group. And what are the future trends? The concluding remark. So what are the new challenges we are going to have? Increasing population, and more cities are getting congested. All the cities are getting highly polluted. And climate change. The temperature of the ocean is increasing, causing changes in the atmospheric circulation, and also we are going to have heavy rainfall and concentrated rainfall, flash floods happening. These were not there earlier. This is happening because of the climate change, rise in the global temperatures. how to have sustainable architecture coupled with sustainable civil engineering, because both go hand in hand. With that, we to achieve net zero emissions. So net zero emissions is nothing but how much carbon dioxide you are emitting in your construction activity, equivalent to that of the reduction in the CO2 emission should happen. So you are not contributing any positive CO2 to the atmosphere. That's called net zero. And raw material. Raghunandan was telling raw material shortage. Globally, the construction activity produces 20 billion tons of concrete every year. Cement production is 4.1 billion tons. And your aggregate requirement is about almost 5 to 6 times. 50 billion tons of aggregate requirement is there, completely want to construct. So where you are going to bring all these raw materials? So my presentation will be working on sustainable products, eco-friendly products. Even my PhD was on sustainable products, the customer acceptance levels. So concrete is the most widely material. The cement was invented by Joseph Aspidin in 1826. Since then, continuously cement is being consumed. As we keep on using concrete for various applications, building roads, bridges, houses, skyscrapers, whatever you want to do, you require cement. But cement is not an eco-friendly activity. Cement production is not an eco-friendly activity because each and every ton of cement produced liberates about 900 kgs of carbon dioxide emissions. So challenges what we have is that we keep on constructing new dwellings, new houses, new roads, new bridges, new flyovers, new expressways, but we need to look into how to reduce the carbon footprint each and every stage. That is our main aspect. How to reduce the consumption of natural aggregates like river sand, natural stone crushed aggregates. This all possible by using cementitious materials or byproducts of the other industry which are contributing to the emissions. How to use recycled materials. These are all very important aspects. We keep on constructing similar way, we keep on demolishing also because old buildings have to make way for the new construction, whether it is a road project, whether it is a skyscraper, because as we keep on developing our metros in the cities, the lifeline will be metro line. Along the both the sides of the metro line, we are going to have commercial activity as well as high-rise constructions, because even the government is approving higher FSI. We keep on demolishing old buildings. What we are doing, we are dumping those materials somewhere, maybe in the dumping yard or the pits we are dumping, and we are not processing it at all. We need to process those materials and extract aggregates, extract sand or fine aggregate for construction. As I'm telling you, this is the global scenario. First, I'm going to present the global scenario. The population growth is continuously happening. By 2050, the world population will be 9.2 billion people, and major contribution will be from the developing countries like India, Bangladesh, Pakistan, China. And as the population increases, there is urbanization. More and more people move towards cities for the betterment of their lifestyle, education. We are already seeing the congested roads, the congested city. So cities are becoming more and more concrete jungles. A lot of pollution, high-rise buildings, and also along with that slums. And India is having the maximum percentage of slums. Go to Bangalore or Chennai, Mumbai, Delhi, slum dwellers or slums will be about 25 to 30% of the total area. Because we have got all type of people living in a city environment. We can't have only high-class people. How to address these issues? These are the various challenges. Traffic jam. Bangalore is having the highest number of two-wheelers, highest number of cars. The population of the vehicle population in Bangalore itself is 1.3 crores. Our population may be 1.2 crores, Bangalore population, but vehicle population is much higher than the population of the people, because people try to own more vehicles, two-wheeler and four-wheeler. So the adverse effect of urbanization is that going to have problems, basic problems, water scarcity, lack of sanitation, poverty, illiteracy, unemployment, global warming. These are the bad effects of urbanization. And we being architects and civil engineers, we have a major role to play. It's not that we cannot change. 10 years ago, Bangalore, people were widening the roads. There was no footpath at all. We felt that there will not be no space to walk on the street. But what has happened? Good architects or engineers suggested we should have good footpath. When we having metro, people should walk to their work. On account of that, Bangalore adopted wider footpaths, smart city project. Today, we can see Bangalore is nothing short of Singapore or any other city. More than 50 cities across the world have adopted the tender sure road model because Bangalore developed it. So that is expanding now. Even in RR Nagar, now they have made wide footpath, concrete roads, white topping. These are all innovations what we have developed. So it's quite possible to change. It's the mindset of our people, policy makers, politicians is very important. So urbanization having both advantage and disadvantages. These are the lists I've taken out. We'll have better medical facility, better transportation, overall infrastructure development, education facility, better internet connection. These are the list of advantages living in a city. The disadvantages are high level air pollution, water pollution, particle pollution, noise pollution, traffic jams, finally lack of natural spaces. So Bangalore has been completely converted into a concrete jungle. Not only in the buildings, all the roads have been done with concrete roads. So even if it rains, there is no proper percolation of water to the ground level. Bangalore receives about 30 TMC of water, which is sufficient to give water to each and every individual who are living in Bangalore, 30 TMC of water. But entire water is drained out because we have created concrete jungle, there is no percolation of water, there is no ground recharging, no rainwater harvesting. Because of that, we are allowing the entire water to flow out of Bangalore. 30 TMC of water which is sufficient for the people to drink, it is not available at all. So that's what we have created. That's what the urbanization is going to create. So the challenges for the future world is more and more concrete jungle, climate change, environmental impact and global warming. So it's all calling for, once again, sustainable development. So recently held COP26 Glasgow summit, each and every government and top decision makers, the world leaders, they all assembled together. They have taken a pledge to reduce the carbon footprint in each and every aspect. By 2030, we are going to have 500 gigawatt of renewable energy. That's the mission. And emissions in terms of carbon dioxide from India, they are planning to reduce by adopting technologies. The world is moving towards net zero by 2050. And we have told the whole world that by 2070, India will become net zero. So to achieve net zero, what we have to do? It's very important for all of us. The drivers are many in each and every aspect for food, for energy, land, for water and construction. There's a great demand because as the population is increasing, we are going to fight for all these things. The next fight will be for water, the world war. They're talking about world war is going to happen for water. Water is going to be a biggest crisis. Don't have sufficient good quality drinking water available for us. So construction, the contributor of highest greenhouse gas emissions. We consume about 40% of the world energy, whatever we produce for housing, and 30% of the global emissions. So imagine, there are so many industries, but construction industry alone contribute 30% of the greenhouse gas emissions. And dust, fine dust, 10% of the world's fine dust. When we construct, we create a lot of dust, fine particles. We do a lot of side mix concrete even today. Because we don't believe in ready mix concrete or going for precast construction. Everybody would like to construct their own house. They want to hire a mestri. Even though knowledge levels are very poor, still we work with him to construct our houses. So with this, the per capita consumption of concrete is going to increase. Which are the materials for construction? What we talked about, madam, using soil, using bamboo. Very good. We should use them. But how much soil is available for us? That is a big challenge. That is the reason construction, concrete, the energy consumption levels for concrete making is less compared to aluminum, steel, glass, timber. Hence, construction requires concrete because energy consumption levels are very low. That's the reason concrete remains the second most consumed material on the planet after water. After water, concrete is the second most consumed material. This is what the cement production. Global production is 4.1 billion tons. India, the installed capacity 500 million tons, but we consume 320 million tons. We are second only to China. And as I told you, cement production contributes 10% of the total CO2 emissions as a product, including mining and other things. By 2050, as I already told you, as the population increases, the cement requirement will be about 9 billion tons. That is the requirement. And similarly, you require huge aggregates, huge quantity of sand. And emission levels are going to be very high. Currently, the CO2 emissions from cement production alone is 2.3 billion tons, which is going to increase multi-fold. So how to bring it down? Because we cannot reduce the cement consumption. That much cement is going to be consumed. So our strategy in cement manufacturing should be such that we are going to have the lowest CO2 emission in cement manufacturing, lowest CO2 emission in steel manufacturing, because these two industries alone emit huge quantity of CO2. And construction is getting advanced. Every time we are going for high-rise buildings. We can see most of the high-rise buildings are coming now only in Asia Pacific, Middle East, World Trade Center, Burj Khalifa, then Kingdom Tower, that is about 1 kilometer. Kingdom Tower in Saudi Arabia, which is being built, is about 1 kilometer tall. So somebody may challenge that and try to construct 1.1 kilometer. So challenges are going towards high-rise buildings. How we can have more high-rise buildings. So when you move towards more urbanization, we go towards more vertical buildings. So requirement for design, eco-friendly design, using technology, using innovation is need of the hour. Earlier we were only talking about concrete buildings, but now people don't talk about concrete buildings alone. They talk about composite buildings. How to design high grade of concrete, because per square feet in MG Road may be 40,000 rupees. You may get a plot of 1,000 or 2,000 square feet. You may get a permission to go 100 floors. If you use low grade concrete, your column size will be 2 meter by 2 meter. So what will you do? You need to go for very high performance, high grade concrete, or using steel columns instead of concrete columns. Because you can charge per square feet maybe 1 lakh rupees, or rental will be 100 rupees or 200 rupees per square feet. So the technology what we are going to adopt, the system what we are going to adopt is keep on changing based on the requirement. That's the reason we are working on metro rail, having more open space, more green cover. So one of the architect in some meeting was telling me, why you require the Bangalore area is about 1,200 square kilometer currently, spread from Devanhalli to here. This is the end, because the road is ending here, the flyover from Bangalore city. The new highway which is being built, Bangalore-Mysore Expressway. So the moment the road ended here, I thought, okay, Bangalore is going to be end here. That is the plan they have done, because they have taken the elevated corridor, some nice road to here, means they feel that Bangalore will end here. The construction will come up to this university. That is the plan. So they were talking about, we want to accommodate 1.2 crore people. We can accommodate. Go vertical. Make wider roads. If you go vertical, the advantages are many. You can have all the people together, provide proper infrastructure, and lesser travel time from work to home, home to work, or shopping facility. There is no point traveling 2 to 3 hours. The productivity of IT people during the pandemic increased 1.2 times or 1.3 times. All the IT companies have posted very high profit during the lockdown, because people could contribute more working from home. Instead of 8 hours, they worked 10 hours or 12 hours. And now many IT companies are telling, you don't have to come to office every day, flexible. 3 days in a week you can come, or once in a week you can come. So a collaborative approach. So pandemic has taught us many lessons, because many industries, they improved a lot during the pandemic time. So there is urgent need for sustainable development all around. So I already told you, this is the biggest culprit in construction for both architects and structural consultants and engineers, is the CO2 emissions, because we cannot work without cement. Our other alternative materials are limited. Soil, if you take out all the soil, what do you do for agriculture? You can only have limited soil usage. River sand, we cannot take out river sand. All the governments have banned river sand because the rivers were depleting. The groundwater was depleting. Now we have moved towards alternative materials, alternative aggregates. So similar way, the emissions are very high, the cement manufacturing. So there is an urgent need because we cannot reduce the cement usage. We need to use cement, but we have to reduce the CO2 emissions. So cement manufacturing as a process liberates about 900 plus kg of CO2. How we can reduce the CO2 in the cement manufacturing? The decarbonization of limestone, because which is the main raw material in cement manufacturing, limestone, natural mineral, that will liberate 525 kg CO2. Fuel combustion in the kiln, 335 kg per clinker, per ton of clinker. Use of electricity, 50 kg. In all these three aspects, that cement industry is working to reduce the carbon footprint, mainly by going towards low clinker cement. Instead of using 900 kg clinker per ton, use 50% or 30% by adopting new technology, new cements called blended cements. So we have already discussed on these points. The emissions are very high. Global is becoming warmer. And you can see this is what the pollution levels globally. African countries, Asian countries emit more pollution to the atmosphere. That's the reason the air quality is very bad. Delhi has become one of the most polluted city. You can't breathe a good fresh air in Delhi. You can see the dark spot. This was tweeted by Donald Trump when he was the president. America is having very good quality air compared to other countries. So greenhouse gas effect is causing the planet to become more and more warmer. So there are a lot of changes in the weathering and rainfall. The urban heat island effect is one more effect which is really causing a damage to the environment. Because as we go and build taller and taller buildings, the circulation of air is affected. That means to say it has to go through narrow passages, and the air will become more and more warmer. So I told you the various industries, how much carbon dioxide emission is happening. Steel and cement, they contribute a lot. The coal generation or the thermal power contribute 60%. Steel and cement 13% or 12%. How to reduce? Because already we are moving towards sustainable energy sources. We are reducing the dependency on thermal power generation. We are going towards wind energy, we are going towards hydroelectric energy, moving towards solar energy, then hydrogen energy. So there we have found a lot of innovative technologies where the dependency on the coal, thermal power generation is reducing. So we need to work very closely on steel and cement, which are the main products used for construction. And India is the third largest emitter, apart from China and USA. China liberates 27% of the total CO2 emissions. And we are contributing more than European Union. European Union together contributes 6.4% of the CO2 emissions. India, 6.6, but it will going to go up. We may overtake America also. The reason behind most of the construction activities now happening in India. It's a big activity. We are building new roads now, new expressways, new railway lines. The new government which is focusing more on infrastructure development We are seeing a lot of development. Every day there's announcement of new road, new expressways. That means to say a lot of materials are required for construction. So need of the hour is moved towards sustainable development, sustainability. Being civil engineers and architects, we need to work very closely. As we cannot stop the construction, but we need to develop technology and solutions. Some of the oldest buildings which are there even after 2000 years, like Roman Colosseum, they did not use cement at all at that time. They used natural pozzolas, but still buildings are there. They used volcanic ash, animal hair, animal blood as an admixture. So they had technologies at that time only to have more durable structures. That means to say, we need to work on the triple line, bottom line. Should have sustainable development, cost economics, and social benefit. All three together, we need to work towards achieving the goals. So using global solutions, using local technology, main agenda of all construction should be reducing the carbon footprint. The general consensus for sustainability is lower the CO2, lower energy and prolonged life. Whatever the structures built forever, once we construct, should not be demolished. Should last like Roman Colosseum, 2000 years. Global versus local. Using local materials, locally available materials, using technology. You may borrow technology from China, America, Germany. Borrow technology, like precast technology, 3D printing. Use locally available materials, use sustainable materials. You have to work towards achieving overall sustainability. So, constructing green buildings, India is the second largest green building projects. America is number one, and India is second largest this thing. We have, I think, 16 million square feet of green buildings in India. So that way we are not lacking. We have got technology, we have got systems, we have got institutions who are helping towards achieving the overall sustainability. So digitalization construction, as already Raghunandan sir was telling, going towards materials, going towards technology, using innovative methods. What are the systems which are available for digitalization construction? Prefabrication, precast construction, the bridge which being built now, the elevated corridor, Bangalore-Mysore Expressway, completely it is a precast construction. We are supplying GGBS, which is an eco-friendly material for the entire construction for Dilip Buildcon. Such a 3-line, 6-line massive structure has been built. It has been precasted at precasting site, brought and aligned together to develop road. Then wireless sensors to know about your concrete quality. We cast cubes. You may be aware also, you may be working with concrete sometime. We cast cubes, then we test it for 7 days and 28 days. But now the technology is available. You have to embed a sensor inside the concrete. Automatically on your mobile you get what is the strength. Every 1 hour, the strength and attainment. You want to demold the structures after a particular strength attainment, you can do it. So this is the technology available now. Robotic technology, automations, building construction is completely automated now. In terms of tunneling, in terms of road construction, more and more machineries are used. Recently they have built 22-kilometer bituminous road in single day and 2.5-kilometer concrete road. This is Mumbai Nasik Samruddhi Expressway. They have built 2.5-kilometer concrete road, single stretch, using more than 30,000 cubic meter of concrete. And all the world records are being beaten by India in road construction. The per day road construction in India is now close to 35 kilometers per day, national highway they are building. This has all happened because of equipments and technology. And 3D printing, I'm going to talk about 3D printing later. It's evolving and much, much faster, where you can design any building using 3D printing technology. So 10 ways to do the best construction using innovations, precast technology, automation, 3D printing, having big data, augmented reality. So the technology is available now. And BIM, drone surveys. Now the survey earlier, people want to build a new expressway. Now they are building no new expressway between Bangalore and Chennai. Recently I visited. They are building expressway between Delhi, Amritsar, Surat to Chennai. Many road projects, many highway projects, many railways, fast train model, everything is coming now. The survey, how they are conducting? Using technology. Using drone surveys. Earlier people physically used to carry the survey tools, survey equipments to physically measure the distance. But now the technology is evolved. And larger projects, who is the person who is monitoring the site? Every hour, people sitting at the headquarters will be knowing what's happening. They have a drone. So, also, this kind of construction requires huge resource mobilization. It is going to be a big challenge. You require a lot of energy and also a lot of materials for construction. So how the future of construction will be, by 2071? We go with 3D printing. Most of the buildings will be done by 3D printing. Then fabrications, sensors, robotics, and buildings will be monitored structural health monitoring systems, all automated. There's a build, this is the elevated corridor. So any problem happens. Recently, Nelmangla Road, the elevated corridor was closed because there was a problem in the structure. Some cables were stripped actually because of the changes in the loads. The traffic on the road was completely stopped. We have not installed any structural health monitoring system in on that bridge, elevated Tumkur Nelmangla highway. That's the reason we were not knowing at all. One of the engineer, general inspection, he has gone and seen the cables were stripped actually. It's not there as per the design. Immediately he has alerted, and all the people, scientists from Indian Institute of Science went and they stopped the traffic on the elevated corridor. If you know in advance what's happening to the structure through sensors, by remotely monitoring, so you can always take proper precaution and repair and maintenance. As we are constructing more and more metros, more and more elevated corridors, more and more expressways, monitoring the structures is very important for all of us. So the future is less labor involvement because we don't get proper trained, skilled workforce. We need to depend on more and more technology, more and more machinery to do the constructions. So future of architecture is moving towards sustainable cities, sustainable landscape, creating more and more urban forest, urban gardens, using green materials, green architecture, using artificial intelligence, blockchain, Internet of Things, future-ready cities. These are the important aspects for architects. Whatever structure you design should adopt using sustainable materials, green technologies, and with less manpower. It should be eco-friendly. It should be with cost economics. You cannot overdo anything, because any client, any developer look for cutting the cost, because there's a competition. Now we have got leading builders, Prestige, Brigade, Purvankara. Many people are building apartments, commercial complexes. They're building IT parks. So how economically you can provide space to the client, he is looking at. So any architect give a higher design for steel or concrete, he'll be disqualified. So any now national level competitions, they are inviting competition for design, announcing cash prizes, 3 lakhs, 4 lakhs, 5 lakhs, which is the best design. And then there are a lot of awards now for the architects and engineers for sustainable design, sustainable architecture. So need for technology upgrades, planning innovation. Look at the buildings. It's an urban forest. You have created trees in each and every floor. That is the future design. How you can combine both architecture, civil engineering, construction together, and living space where people get pure oxygen from the trees which they are planted on their terrace or their floors. And advances in concrete. No longer we use M20, M25, M30 grade concrete now. The grade of concrete has gone M150, M200. And people have designed without reinforcement also. It's called reactive powder concrete, where the strength of concrete is equivalent to strength of the steel. M700 grade concrete, where you don't have to put steel at all. These are the innovations which are there. How much more time you have? 10 minutes, huh? Okay. So going vertical, that is the only solution. As I told you, 60% of the people by 2050 are going to live in cities. Imagine the population of Bangalore. 1.2 crores is now. It will be not less than 4 crores, Bangalore population. Mumbai may be 10 crores. So we need to go on more and more vertical. So if you go on more and more vertical, you require oxygen for all the people. You need to go with vertical gardens, vertical transport, the lift. If you are designing an understory building, the speed of the lift is very important. So urban vertical transportation is very important. Vertical cities, to build vertical cities, not horizontal cities. So new technologies, precast homes, 3D printing, dry wall technology. These are all latest innovations. You make walls, then put the beam and column and install walls and construct the house. Shear wall technology, through Maiwan formwork, aluminum formwork, we can pour the entire building concrete at one shot. Column, beam, everything has been done. This has developed very fast in India. Most of the builders in Bangalore now, or in any cities, they are going for Maiwan formwork technology. Many buildings have been constructed. These are the best examples. Mantri Pinnacle, Pashmina Waterfront, and Presidential Tower, which is under construction. They are all using Maiwan formwork. So that construction is much faster, superior, high quality. Completely eliminating the plastering requirement, because it is concrete wall. Using M25, M30 grade of concrete you are using. So there is no plastering at all. you can finish the building much faster than precast high-rise buildings. This is one more technology. This is the happening building in Bangalore, Provident Park Square project, where they're using technology to build and also using sustainable material like GGBS here to cast the precast elements. The precast segment, the joints are very important. Vertical and horizontal joints are very important because there should not be any leakage through the joints. Otherwise, it will spoil the buildings. Then, government mass housing project, because Prime Minister Narendra Modi, sir, has given a mission for the housing department to provide houses to all the people. That's the reason new technologies have been evolved now. Light gauge technology. This is light gauge steel constructions where you can construct the buildings. I request you all to visit. There is one society for composite near Kangeri only. I know the director there. They are developing this technology. I request all of you to visit. I request the architectural department. I can provide the lead. They have developed new materials which are lighter and can be used for construction. Many demo of construction also has happened there. I'm a part of the technical committee there. I'm the chairman. And 3D printing technology, which is acceptance everywhere. This is first 3D printed house in India. Then 3D printed structures abroad. You can print the building. And using mud, they have done 3D printing. So, 3D printing can make use of any material. I have supplied our JSW slag, GGBS and slag sand to IIT Guwahati. They have printed one chair and table. I have already suggested them to print window frames and door frames. So 3D printing is one technology which is going to change how the architecture is defined. You can design any building, whatever shape you want, because most of the time architects find it tough to convince the structural consultant. He always say, no, I cannot provide reinforcement here, I cannot design it. So you change the shape of the building and all. So with 3D printing, whatever you can imagine, you can print. So coming to the concrete, I don't take much time. These are the innovative technologies for the younger generations. Concrete is one more material which is used abundantly. And earlier it was only a mixture of cement, sand, aggregates, water. But it has become a mixture of so many admixtures. Today we use in concrete mineral admixtures like GGBS, fly ash, microsilica, metakaolin. We use fibers. Why we use so many materials? To make it concrete sustainable. If I use only cement, it's not sustainable. So concrete should be sustainable and durable by using recycled materials, lesser energy, should be light in color, should have a better finish. That's what we all expect from the concrete. And also we want various properties in concrete, the fresh properties like placing, and also ardent properties like durability. These are the important requirements for concrete. So durability of concrete is very important because we all architects and consultants, engineers, we use so much of concrete. So concrete should be resistant to all these sulfates, chlorides, seawater, alkali silica reactions, and there should not be any corrosion of reinforcement. And should be against carbonation and chloride attacks. So challenges are more in concrete. We need the concrete to be an ideal, having very good particle packing, but in practice we have a problem. The concrete will have more of voids, more of cracks. So enemies of concrete are sulfates, chlorides, carbonation, moistures. All these should be overcome by adopting technology so that The ideal concrete doesn't have any voids. It's protected. The reinforcement is protected. There is no seepage of water. So by adopting technology in each and every aspect of concrete, in cement using supplementary cementitious materials, aggregates using recycled aggregates, and for fine aggregates like sand using sand, using slag sand, using recycled water, improving durability of the concrete. These are the important aspects in construction. So using mineral admixtures, using chemical admixtures, using alternative to river sand, alternative to coarse aggregates, these are the important aspects. To make the construction sustainable, adopting technology, adopting materials, adopting systems, adopting innovations, adopting 3D printing technologies, robotics, these are the main things. Being architects and civil engineers, what I would like to say is that every day the material science is evolving. What was difficult to make M40 grade concrete, it's easy to make now M100 grade of concrete because of innovative materials, innovative admixtures. What was difficult to make high-rise buildings, it has become easy using My1 formwork. The cycle time to construct one floor, we used to take 1 month. But now, in 3 days, we can raise 1 floor using My1 technology. The road construction, which is happening in front of you, they are using the most eco-friendly materials. Using precast technology, they have built the 10-kilometer elevated corridor up to your college in no time. It's all possible because of the technology, innovations. So my last concluding remarks is we should adopt technology, we should adopt innovations, should use our brain power. Everybody should be having an entrepreneurial mind, that you should not feel that I always go to a job and work. Many very good architectural firms are there in Bangalore. Leading architects are there here. Zakaria, Thomas, then we have many multinational companies working here. Many top structural consultants are there here. RSP Group. So Bangalore is the hub for innovation. All my classmates who are doing architecture in the VC college, they have become leading architects now. Everybody is practicing sustainability in their practices, whatever the houses they construct. Indian Concrete Institute also has installed many awards, not only for the high-rise buildings, also for the individual house builders. Each and every district we have got award. Every year we give awards for the innovative structures, innovating building construction using eco-friendly materials. Because saving the natural resources is very important. Adopting sustainability is very important. Reducing the carbon footprint is very important. So I hope all of you will work towards making the world a better place, achieving the Indian goal of achieving sustainability net zero by 2070 is in front of all of us. We from JSW always there to support. If any materials are required for your R&D work, like cement, sand, we will be able to provide you. I don't think we have a concrete laboratory for architects, but you can visit our factory also. I can organize a factory tour to our Bellary. There's Hampi, natural, that is the World Heritage Center is there, Hampi. Near that only our factory is there. You can all visit our factory, see how we are developed technologies, developed new materials there, using the steel industry byproducts. And we have become a global leader. Our total carbon footprint is only 214 kg per every ton of cement production. The global average is 600 kg. Indian average is 560 kg. So I thank Christ University for providing me the opportunity, Jyoti Madam and Architecture Department and Raghunandan Sir, because I'm the second lecture I'm delivering within a span of 10 days. So I thank you all for giving me the opportunity to deliver the today keynote address. I wish you all the best in your future endeavor and your career. Thank you.
Thank you so much, sir, for an eye-opening session. I'm sure that we all had immense takeaways and infinite learnings from today.
Before we conclude today's session, I request Father Jibby and Dr. Anita Sushilan to kindly hand over the memento to our esteemed speaker as a token of appreciation. With that, we have come to an end of today's event. Now, I would like to call upon Uzam Akhtar to deliver the vote of thanks.
We'd like to thank respected Father GB and Dr. Father Benny Thomas, Dr. Father Abraham in their absentia, heads of departments, professors, students, and our honorable chief guest. I, Uzam Akhtar, from the School of Architecture, take great honor to propose today's vote of thanks. First of all, I would like to extend my gratitude to our distinguished speaker, Dr. L.R. Manjunatha, for his excellent and insightful talk. I express our profound gratitude to the head of the Department School of Architecture, Dr. Anita Sushilan, for her constant support and guidance. A special thanks to Professor Jyoti Gupta, the faculty coordinator, and Nishita Iyer, the University Student Council representative from the School of Architecture, for their added help and support. I thank the staff members, student, event coordinators, and the School of Architecture student body, UNCH, for all their efforts and hard work that has helped make this seminar such a resounding success. Last but not the least, thank you, our wonderful audience, for participating in this wonderful seminar. Thank you.
I request everyone to please rise for the college anthem.
March on,
Henry Ford once said, anyone who stops learning is old, whether at 20 or 80. Anyone who keeps learning stays young. We hope that each one of you present here takes home a new slice of learning for your future endeavors, and that you are one step closer to understanding your paths better. Thank you all for being a wonderful audience. This is Jasha Cherian and
Mayank Kashyap.
signing off.
Thank you.
Just for the benefit of the audience, a feedback form will be circulated in your respective groups. Kindly fill in the same. Thank you and have a lovely day.